Imagine you are building a modern mobile application. To reach 99% of the market, you must release on both Apple's iOS and Google's Android platforms. This historically meant hiring two separate engineering teams to write the exact same application twice, once in Swift for iOS and once in Kotlin for Android. Or you used hybrid web-based wrappers like Cordova or bridge-based frameworks like React Native. But the bridge architectures introduced massive performance tax, serializing data overflow JavaScript bridge to talk to native OUI widgets at 60 frames per second. The result is dropped frames, sluggish scroll animations, and complex, fragmented codebases. In 2017, Google released Flutter to completely bypass this native widget bridge architecture. Instead of translating your code into platform-specific OEM widgets like UView Controller on iOS or ViewGroup on Android, Flutter does something radical. It ships its own lightweight rendering engine, Skia, and more recently, Impeller. Flutter views the device screen as blank canvas and draws every single pixel itself using hardware-accelerated APIs. This means your application looks and performs identically on 10-year-old Android phone and brand-new iPhone 15 Pro, completely bypassing the OI's native layout engine to render at silky smooth 60 or 120 frames per second. To manage this high-speed drawing process without wasting device resources, Flutter employs an architectural system known as the three trees. At the top level is the widget tree, which contains lightweight, immutable configurations of your user interface. When a widget state changes, Flutter does not redraw the entire interface. Instead, it compares the changes against the secondary element tree, which manages the logical lifecycle and coordinate. Tree updates. The element tree then updates the tertiary render object tree, which calculates layout dimensions, paint boundaries, and actual pixel coordinates. This separation allows Flutter to rebuild UI configurations in microseconds. At the heart of Flutter is Dart, an object-oriented, class-based language developed by Google. Dart is uniquely suited for client-side development because it utilizes two distinct compilation modes. During active development, Dart uses just-in-time, or JIT compilation, which injects code changes directly into a running Dart virtual machine. This enables Flutter's legendary sub-second hot reload feature, allowing you to modify your UI and instantly see the results without losing your current application state. However, when you compile your app for production, Dart switches to ahead-of-time or AI compilation, generating highly optimized native ARM and UX machine code. In Flutter, the foundational philosophy is that everything is a widget. Padding is not a property of a view, it is a widget. Alignment is a widget. Touch gestures are captured by a gesture edit vector widget. Flutter constructs complex user interfaces through structural composition rather than deep class inheritance. The layout process follows a strict and predictable rule. Constraints go down, sizes go up, and then parent sets position. A parent widget passes down layout constraints like minimum and maximum height to its child. The child calculates its own dimensions based on those boundaries and returns its size. The parent then decides exactly where to position the child on screen. A critical design pattern in any mobile app is how it manages data flow and state changes. Flutter differentiates between ephemeral state, which is completely localized to a single widget, such as the active tab index and navigation bar or an ongoing loading animation, and app state, which must be shared across many parts of your application like user authentication tokens or shopping cart data. For simple ephemeral state, Flutter utilizes stateful widgets and the build and set state method to mark the widget dirty and queue frame rebuild. For complex app state, developers rely on robust architecture patterns like provider, riverpod, or block. Let us examine the structure of a standard stateless widget in Dart. The class extends stateless widget and overrides the core build method, which takes a build context and returns a widget. The build context provides a reference link to where this widget lives inside the overall widget tree, letting you look up themes or media queries. Within our build method, we declare our structural layout. We return a scaffold widget, which acts as a visual wrapper providing an app bar and a body consisting of a center widget. This center widget aligns its child directly to the middle of the screen, which holds a column widget stacking a text label and an elevate button. While Flutter began as a mobile-first framework, it has evolved into a universal rendering canvas. From a single shared codebase, you can compile and deploy apps natively to 6 major platforms: iOS, Android, macOS, Windows, Linux, and the web. For desktop platforms, Flutter wraps your application in a native runner shell and compiles your Dart code directly to native C++ binaries. For the web, Flutter compiles the Dart code into optimized JavaScript and offers 2 rendering pathways: HTML and ESS for small bundle sizes, or CanvasKit, which compiles the C++ SKIA engine into WebAssembly to render high-performance graphics via web.